Hey, I'm Taylor Dorsett, and this is the Professional Technical Interviewee. Technical interviews are hard, and every company does them differently. On this show, I interview engineering leaders to see what they look for in technical candidates, and then they perform a real technical interview with me. My guest today is Jeff Miller. He's currently the Senior Director of Platform Engineering at Yellow. He's also worked at companies like FUDA, NCSA, and Innova here in Chicago. He's mentored and spoke to many coding boot camps, so I hope you enjoy.
Cool. All right. Well, we're back with Jeff Miller. The ball is in your court now. I am ready to interview.
Sounds good. So I don't give this long a context, but this is a question that I wrote based on an interview I was giving with Northwestern's for their boot camp, I think. Mm-hmm. And this problem came up during a conversation, and I'd never heard of it before. So I was very curious by it. So I went home and wrote the code to prove this. And I was like, this would be a great interview question. It only takes, about an hour. I know we only have about a half hour here, so we'll see what we can get through. But basically, it's based off of a game show from the 70s hosted by Monty Hall. It's called the Monty Hall Problem. And I think it's Let's Make a Deal was the game show. And at the end of the show, there were 3 doors. And the contestant would choose one of the doors. Behind two of the doors was a non-prize. I think it was a goat in the show. And then behind the final door, there was a prize. I think it was a car. Mm-hmm. And so obviously the candidate wants to get the car. So, or the contestant wants to get the car. So they choose one door. The game opens one of the doors they didn't choose. Mm-hmm. Obviously, if the car is behind that door, they lose, right? We know the other 2 are goats. But if it's a goat, the Monty Hall, the host of the show, gives them the opportunity to keep their choice or switch their choice. And, as humans, we have a cognitive bias to want the thing we've already chosen. So oftentimes the contestant didn't switch, but it's a little fun fact that if they do switch, they have a 2/3 chance of winning the prize. But if they keep their original choice, they only have a 1/3 chance. And it seems very counterintuitive, right? It doesn't seem like that should be the case. It seems like it should be 1/3 for any choice they have. And so the problem is the interview question is to model this scenario in code and then run the simulation 10,000 times and demonstrate that, in fact, it is better to switch your choice.
Interesting. Okay, this is a fun one. You mentioned it before the show, and now I'm remembering I have heard of this scenario before. Okay, so you sent me kind of the write-up.
So this is the problem statement. So again, this is modeled to be a take-home problem. So we give the person a description of the problem. It's in just a Wikipedia link. With all my take-home tests, I like people to use Git, and we pretty much insist on it. They can either send me the repo once they push it up. Again, I'm not really terribly nervous about the question getting out. So if somebody pushes it to a public repo, c'est la vie. Or they can send it to us in a Git bundle. But so I just give them a little intro on what I'm looking for from a Git standpoint. What I'm looking for, I guess I could have covered this in the first part of this interview, but I'm looking for their commit posture, right? Do they write meaningful commit messages? Do they commit early and often? Do they when they wrote the test, when they wrote the code, did they write tests first? Did they write tests last? I don't really care. It's just interesting for me to see their thought process, especially if they, do commits along the way. If it's just one big commit at the end, we'll probably have a conversation about that. Sure. Not in a negative way necessarily, but why did you do that? Did you have would you break it up in any way? Because it's my opinion that when I'm functionally coding, I do like to commit frequently and commit in small chunks and And anyway, so that's why we ask for them to use Git, and then basically it just says the goal is to run it 10,000 times and demonstrate the results. So
yeah, interesting. Okay. I think I understand.
And then what we're looking for in the bottom is notes for my interviewers, right? One of the reasons I like this problem is it can be solved in an object-oriented way, it can be solved in a functional way, it can be solved in a procedural way. So it's really open-ended like that.
Yeah. Okay. Well, I think I think I understand what we're trying to do, right? Well, I guess my first question, and this is probably a question that I would ask is, what are you looking for as a result? Are you looking for a true false statement, or a um how many times each scenario came out? I guess what would your ideal result be?
Yeah. So I would say it's open ended, right? I don't
Mhm.
really have an exact. I can't give you the exact template of what I'm looking for. Just
Yeah.
demonstrate to me that it is better to switch, right?
Mhm.
I think the percentages are interesting. So if you want to show that to me, but I don't have an exact format that I'm looking for.
Okay. Interesting. Let's write this out. Our output. I think percentages are interesting. 2/3 chance of winning by switching your door versus a 1/3 chance of winning based on keeping your original choice. And I can't remember. It's been a long time since I've run into the question, but is it or looked at this? Is it like basically a direct split? It's going to be whatever it is, 70-30%. So of the 10,000 times, it would be 7,000 times it comes out and 3,000, or is there some variance?
There will be some variance. Yeah. I
Okay,
mean,
right.
it's a likelihood. So it should trend towards 66-33, but I've seen anything from like 70-30 to
Okay.
like 60-40, but it should generally be very close to 66 and 33.
There's not exact goat science here.
Not exact science. No.
Okay, great. So we'll say a percentage of times it was true versus false. Um, so something like 66, comma, what is that? 34 would be the actual output.
Yep,
Or
looks good.
yeah, we're just doing percentage. Okay. And then as far as how I would approach this, so this is interesting because there's multiple parts, right? I think first we're talking, we're going to need something to actually run the simulation, code to actually run the simulation, and then I guess something to collect that. So I would think of a function. Um, I'm trying to think of the pieces that I would need to build.
Yeah, so I think your first, and I probably wouldn't give this much direction on an interview, but I think your first choice is deciding how you want to model the problem.
Right.
If you want to do it in a procedural way, I've seen it done with like just arrays that track all this. Or if you want to write functional code, like an Elixir type
Mhm.
of pattern, or if you want to model it in an object oriented way.
Yeah. What do you think is functional is not the best option for me. Is not familiar with that.
Yeah, no worries. I would, I think objects are pretty interesting. The objects are really small in this case,
Mhm.
and so you can demonstrate good understanding of object-oriented programming by showing good discipline on how you would break this stuff up.
Yeah. Okay. Interesting. Um,
But again, if you want to do procedural, I'm happy to walk through that as well. This code is also all on my GitHub account, and I did it in an object oriented way. It's just how my mind modeled this problem. But
yeah.
honestly, most candidates did it in a procedural way.
Yeah. What do you mean by procedural way?
Just basically like a single method. Generally not even a method. Just like just running a script, going through loops and just not breaking up the problem, just kind of solving it right in line.
Right. Right. Because that's where my brain went is like, I mean, if we're trying to do something 10,000 times, can I just write a chunk of code and then do, say, 10,000 times do this, right, on this array or on this however.
You will still need to do that portion, kind
Yeah.
of in a procedural way. But whether you're going to model the game with like a game object and door objects, that's one way. Versus if you have like an array of like 3 items that models the doors. You see what I'm saying?
Yeah. Right. Interesting. Maybe do you want to pair through this? This might
Sure.
be helpful. Because I think I understand the question. I think this is one where like if I saw it, I go, I don't know if I have a good starting point. I feel like that's the difficult part. I don't know if I can.
So are you good with solving it in an object-oriented way?
Yeah. Be interesting.
So what I think about first is what are the objects involved here, right?
Mhm.
There is a game. There's a scenario that we're in.
Right.
Let's call it a game because it came from a game show.
Mhm.
There are doors that are involved in this game, and there are a prize, or I called them prizes, but obviously the losing prize is I guess I'm still qualifying as a prize.
Yes.
So those are to me those are the essential objects. Maybe it could be broken down in a different way, but that's how I thought about the problem. So we can go from the macro to the micro, or from the micro to the macro. So I don't remember exactly how I started this problem. I think I started with the game and wrote some tests that failed, right off the bat. Oh, actually, it looks like I didn't write tests on this one. Shame on me.
Oh no, Jeff.
But that's how I would have. I guess that's how I would if I was in this scenario. So so a game is comprised of 3 doors, right? So I would, let me see, let me get back to your screen here. So I would, so where do you want to start, do you think? At the game or at prize level?
Game makes sense to me because then we can adjust. But at least if that's in place, then we can slot the other things into it.
Exactly. Okay. So so let's just start it out here. So it looks like you're going to use some JavaScript. Not my best language, but I can help us get through that.
I can do Ruby too. If
doesn't matter to me.
If that's easier for you, yeah.
Sure. Let's go for it. So I would just start it with a class of game end, and then think of the attributes that we need for it. So in Ruby, we capitalize the classes. There you go. So we're going to have an initialize method. We're going to have we could start with the attributes or the methods, but we'll have an initialize method here. Sneak peek as to like when we do go through this problem, I ask people to, well, how would you change your solution if instead of 3 doors there were 5? And so I make the number of doors configurable in my code because, like I said, I want people to tell us how they would change the problem and what would be issues with that, right? Because now you have new business logic or new rules you have to come up with. Like how many guesses do you get and all that kind of stuff. So it drives a different sort of conversation. But that's the kind of conversation I'm looking for. So, so let's see. And then we also changed the game style on people. So I'm going to take that out of it for now. Sure. So let's see. What do I have here? Oh, so we have the player's strategy. So we need to know if so we're running the scenario where they switch and where they don't switch, right? So that needs to be configurable in this game. Theoretically you could model a player. I didn't do that in my solution, but you could use a player object, but but I didn't do that. So yeah, I guess the initialize method will create the game object. So I basically just put a def there, and you got that method at the beginning of the yep. And let's leave it all non-configurable at this point. We'll just do the basic solution. And so I modeled the doors with an array in this object. So an array of 3 doors. So you could initialize that there.
Oops. Just an empty array?
You could do an empty array, or since we know we're going to just model the classic game, you could create the 3 doors in there. So door.new, and we will fill in the which of those are yeah. So capital door.new, and then in Ruby you can just do ×3, I think, or you just do door.new 3 times. I think that gives you an array of 3, but we'll have to open a console and check that out. Let's see here. But anyway, so then we have to model the player's choice. So I would just make a variable in there called player choice or something like that. And then I just use symbols. So I just said colon switch or colon non-switch. And I defaulted it to no. And then if they do switch, then I set it in the game, but it's up to you. And okay. And then let's see, what else do we have?
Sorry, you said colon switch or...
Yeah. Well, you wouldn't put the or there because then that's going to actually evaluate as a Boolean.
Right.
So basically when we model this in our loop running 10,000 times, we will have to configure if they're going to switch or not switch. And so you can add that as a parameter to initialize, or we can create a method to change that, but we'll have to configure the game when we're simulating this.
Okay.
Does that make sense?
Yes, but how do we functionally write that?
A comment there, so we know the 2 choice, not a comma, a comment. Sorry about that. Yeah. So just so we know if it should be like what the values are, basically.
Yeah. Okay. Around the whole thing.
I would default it to one of them. But yeah, put a comment there so we know what the appropriate values are.
Yeah. Okay.
And yeah, so then we need one of the doors to be a winner and 2 of them to be not winners, right? So this kind of jumps forward to the door, like to the door object, but I gave the responsibility of what's behind the door to the door object, right? And
that makes sense.
The game doesn't control that. So so basically one of our doors, we need to have it again be a winner and then 2 be failure. So we can either just assume those methods exist and go fill them in later, or we can write them now. Kind of the ways of going about this. So
yeah, do you want to build those in door?
Yeah, sounds great.
Do we need an initialize method in this as well, or we'll skip that and then come back to it?
We'll need an initialize method here. So what is the essence of a door? It has what's behind it, and it has, so I called that the prize again. So I would create a variable here called prize, and we have, and I would default it to let's see, what do I have? I have it configurable, right? So you want to put it as a parameter on the initializer, or that's what I did at least. So
Or
you
am I
can do
thinking
this dot,
JavaScript?
or you can do an instance variable. I used instance variables, so an @ sign in front of the prize.
Right.
And I didn't find enough value in prize being a separate object. So I modeled prizes just with symbols. You could do 0 and 1, but I find these mystery integers to be kind of confusing in production code. So
Sure.
in Ruby, I would rather use a symbol, which tells me exactly what that thing is. So
Yeah.
I would default this to goat, so :goat, and then on the initialize method, I would put a parameter there. I called it what is inside, but you could call it whatever you want. What you could call it prize, or you could call it whatever. So after initialize, I would put the parameter that's coming in. So again, call it prize or call it what is inside or whatever you want, and then default that to goat.
Equal goes. That's
:goat. Yep.
:go.
Yep, that's the symbol for goat. And then change your symbol down there to what to that what inside. Yep.
Yeah. Okay. Makes sense.
That way, if we want a door that has a car behind it, we just pass in car to that parameter. Okay,
sense.
so then the other thing, so we won't need that prize class. Again, you could build it out. It's just it's so simple. I just chose to use symbols.
Yeah.
So the other thing that a door has is it has a state. It's either open or closed. So I would create an @state variable. And this one, we want to default it to close. There's no scenario where a door would start open. So, yep, exactly. So there we go. So then I didn't want an external class to have to know my my shorthand for the prizes. So I created a class method. I created an instance method, but also a class method that basically said create a winner, and we know it defaults to loser. So again, this could be so I would do a class method. So door. So then all you have to do in your game class is basically say door.create winner or door.new, and that will give you a loser door. So
yeah. So make that within.
So in the doors class, a class method starts with so you do def, and then self dot, and then I called it create winner.
Yeah.
It would actually be more syntactically appropriate to say new winner, because we're not actually creating it. In Ruby, create means it's going to make a new instance and save it to the database.
Oh, really? Interesting.
So we could say new, because then it'll because that's all we're doing is new object. It's just an object in memory. So that's more syntactically appropriate. And so I would just say, and here it's just door.new, and then pass in car, :car. Yep.
Right. Why don't we get the doors and the game in place, and then I will do off recording. I'll write the actual logic for running it, and then I can post this along with this portion for people to do on their own if they want to run through it. I think that makes sense. I think would work within our time constraints.
Yep. So now in our door array up in the game, we have enough here. It's not the full doors class, but I tend, again, to kind of go back and forth between the objects, because hopefully we would have tests around this that would say, ensure a game has 2 loser doors and 1 winner door. Ensure that these other, these other things that happen. So one example that we'll hit down the road is what if you try to open an already opened door?
Oh, interesting.
And the door object shouldn't allow us to do that. So anyway, these are all scenarios we could test for and we could obviously code for. So back up in our game array, we've hit where we were at. So instead of the door.new times 3, let's just change that to a literal array of so open an array and then door.new.
So you're saying,
so sorry, square bracket, yeah, and then door.new, yeah, square brackets there.
right here, yeah.
Yep. Door.new in the array. Yep. And we don't need don't need to pass anything to it.
Great.
Comma door.new.
Those are 3.
Well, and then the third one, it will be door.newWinner.
Right, because
We want
is this so we're gonna start doing the modeling?
Yeah.
There's gonna be one winner for each door. Okay, that makes sense.
Exactly. And then at the end of the array, we'll just put dot shuffle.
Mhm.
So that will randomize the order.
Yep, that makes sense.
I forgot, where did you want to leave off?
Basically, once we got game in place and then doors in place. I mean, I think.
So there's more to a door. So we need to know if when you are running the simulation, you'll need to know, or it'll actually be in the game. You'll need to know if a door is a winner or not. So we'll need a method for that. We'll need a method to know if it's a loser, which is I've just defined it as exactly. So
oops.
Yeah, it's just winner, and then in Ruby we have we can put punctuation on methods. So I put winner question mark, and that indicates to me that it will return a Boolean.
Right.
And then loser question mark. Yep. And loser we can quickly implement because it's basically not a winner.
Yeah.
And then we'll define winner in a second here. So just put not like a exclamation point and then winner.
Yep.
And then for winner, it is if the prize, which is at prize.
Right.
Equals a car. And it's double equals because we're evaluating truthiness.
Yes. And a colon, right?
Yep, exactly. So the door is a winner door if there's a car behind it, and it's a loser if it's not a winner. So we also need to open and close doors. Or well, we don't actually ever need to close a door. We just need to open a door.
Right.
So and then we'll need to know the state of the door. So we'll want very similar methods to this, but def open question mark and def close question mark. And since they all start closed, I chose to implement open and basically closed as if it's not open, right?
So same type of thing.
Yep. So same type of, and you could do all of this stuff in, obviously, you could just say if it's not open in the game method, but to me, it's just much more readable code if you are directing the object to do exactly what you're asking. So if I want to know a door is closed, I'll ask it if it's closed versus are you not open, right? It reads better.
Yeah, that makes sense.
So then if it's open, the at state will be colon open. Yep, you were there.
Yeah. Right, because we're not setting it to be open.
We're not setting it yet. Yep.
Yes. Yeah.
But we will need to set it, and we could do that next, which is so if you create an open method, and again, punctuation helps in Ruby, helps understand what the method does. So if you create an open exclamation point method,
yep,
that changes it generally changes and saves the object. I chose to write it this way to demonstrate to the interviewer that I know what, like it will spark a conversation about why did you use an exclamation point or why did you use question marks? And I can demonstrate my knowledge about the language with that conversation, right? And so I try to write my code in such a way. That's why I would also implement loser methods and closed methods, because it allows me to talk with the interviewer about readability and about like maintainability of code. Because maybe in the future there's multiple states like open, partially open, and closed, right? And so you might have to implement different logic for closed. So to me, let's just start there, and it's more readable, it's more extendable in the future. Like it's a starting point for something in the future. So so for the open method, what do? We just change the state to open. Yep. And then what I chose to do, which I don't know if this is, I don't know if this is the best coding practice, but when I open a door, I want to know what's behind it. So I opened the door, put the state into open, and then returned the prize with this method. Again, that might be not the most object-oriented, because I'm getting a prize when I tell a door to open, which is kind of strange. But to me, that modeled reality better. When I open a door, I see what's behind it. So we can, that again, fosters a conversation with the interviewer about the design choices. But honestly, I don't know what an object-oriented purist would say about this.
Sure. That makes sense.
So
just returning. Yeah.
Yep.
Yeah.
And then
Jeff,
if
you
we
know what we haven't been doing?
What's that?
You know what we haven't been doing?
Is writing some tests or committing along the way. Yeah. That is correct. So I think if I'd have to, hopefully I'm practicing what I preach here, but I'd have to look at my commit history on this. I think nope. I just did an initial commit and then a couple refactors. Was a very poor commit message, but anyway, yeah, I generally would write one object.
Yes.
Or if I'm going back, it just kind of depends on how I'm writing it, right? It might be one object and then commit that. It might be getting a very bare bones, not even implementing the methods, just implementing the prototypes of the methods, like what I think they will look like, and then commit that and then come back and fill it in. That's sometimes how I write these things.
It might make sense too, is like, I think of it as like, what is the train of thought that I try to commit and train of thoughts where it's like, great, I've got to initialize on both of these, commit that, right? And then I probably wouldn't commit just for winner, but winner and loser, great, that's done now. And then open, close, done, right? Like,
that's a lot of commits, but I think that is a very good mental structure to go through, for sure.
It makes it a little harder in GitHub, because there's a lot, but it also makes it easier to write a commit message that is actually relevant, right? Where you're saying made open, made closed.
Yeah. So the only other thing is if we want to future-proof this, and in our open bang method, we could raise an error. So it's at the top. It's called a guard clause, basically. So at the top of the open method, we would raise an error, and you can I called it the already open error, but so raise.
Is it just?
It's just lowercase raise. Yep.
Yeah.
And then the first parameter is what you want to call the error. So I called it already open camel cased.
Yep.
And then comma.
I haven't used raise errors before.
Yeah, no problem. And then comma, and then what you want the message to be. So I put quote, the door is already opened.
Yeah.
And when do we want to raise this? It's if the door is open.
State equals open.
So at the end of that
third parameter.
Oh no, sorry, it's not a third parameter. It's at the end of that. Yep. So if space if, self.open or just open. question mark.
Yeah.
So this, again, I would put statements like this in to, again, foster that, yeah, it's open question mark. Yep.
Yeah.
To foster that conversation with the interviewer, basically showing them I thought about this scenario, but also like, a guard clause is very common in production. That's what this first line of the method is. So
Yeah.
if you're going to do a method and it's already maybe in a state that you shouldn't do that method, you shouldn't run that method if it's in a certain state, or maybe you're in a shopping cart and somebody took something out of the shopping cart and you want to, if there's maybe a scenario or another bug somewhere else where you're at 0, you don't want it to go negative. So these type of clauses are common, and so this again helps demonstrate that I've thought through the problem and that here's how I would handle it. That also allows you to catch that error in the game clause if something happens. In our case, we're fully in control of this, but maybe there's an ability for you to do command line interaction with a user, and they choose to open an already open door. You can then catch that error, guide them on what they did wrong, and continue on the application from there.
Yeah.
So
Great.
all right. So now we go back to our game method, because that's, to me, that's the extent of the door class.
Yes.
And let's see, what do we need to do here next? So
Something with player choice, I'm assuming.
Yeah. So, well, let's see. We're going to. So I think actually you could go ahead and start creating your trials, and build and figure out the methods that you're missing in the game class based on what you're going to need from your trial, right? So you can either
When you say trial, you mean what would actually be running this?
Yeah. So what's going to exercise this code? What's going to run this 10,000 times? So I think maybe that's either the place to stop and have you kind of fill in offline, or we can do it together and just kind of figure out what methods we're missing. I could dictate to you all the methods that are here that I needed, but that doesn't necessarily mean they would be the methods you would.
Yeah. Interesting. Okay. Well, I think is that repo public?
It is. Yeah.
It is. Cool. Then I can link to that as well as linking to this and then the problem, if you're fine with that. And then I think there'd be for people to be able to run through, if they want to look through this. And I think, sorry, what approach did you call this type of approaching the problem?
Object-oriented approach.
Object-oriented, right? Okay. Yeah, I think this is helpful because, especially earlier career, like this is the type of stuff you start to step into, and like I haven't done a lot of these before. It's more reverse a string, and I'm like, okay, I can do that. Write one method, and then we're done. Versus like now we have to do things that actually is going to build on top of each other.
Yeah, and to me that goes back to my philosophy that I want to model our interview problem as close to the software that the person's going to be writing on a day-to-day basis.
Yeah,
right?
yeah.
So if you're writing a fintech app, you're almost certainly going to have a loan object or I guess it's a lending app, not necessarily fintech, but like you're going to have a loan object. You're going to have all these different objects that you're going to be contributing to if you're in an object-oriented shop, and so that gives you a way to solve it, but also it accommodates for if you come from a functional background and you want to write a functional programming program, or if you again just want to solve it procedurally, that's fine too.
Yeah. Well, thank you for walking through this because I think this is helpful. And obviously, there's more components to it and kind of that engine side. But I think this is helpful to people who haven't thought in terms of this is how you would design something. It's actually a former Nova engineer as well, Tyler Jefford, who I like Tyler a lot, and he's giving me advice around this type of problem. He's as much as possible try to build it rules based, right? Because then you can actually go in and edit it later versus just like it's kind of stuck and then you have to rebuild the whole thing if someone changes it up, and they always change it up in an interview, right?
Yeah, Tyler's great.
Yeah. Any other advice or any other tips you would give on someone that was approaching an interview question like this?
I guess I would just say similar to the knowing a language and honing in on a specific language. I would also just either know yourself pretty well and how you like to solve problems, and to me that oftentimes means object oriented. But I can do the other other types of code structure, whether it's functional or procedural. It's just my mind goes toward object oriented right away, and so
Sure.
how can I model the problem? And it just, to me, it just again takes one more thing off the table that I don't have to worry about when I'm in the hot seat, so to speak.
Yeah. Well, it makes a lot of sense. Great. Well, before we wrap it up, anything you want to plug or anything else you want to share, Jeff?
No, just again, have confidence in yourself. You've put a lot of time and effort into the skills that you have up to this point. You're, we as interviewers hopefully know what we're hiring for, right? It's an entry-level role, so we're not expecting the world from you. And so we're mostly like, be collaborative, be, really embrace the interviewer and try to, bring them along in your thought process. And I think, hopefully you'll do great.
Yeah, absolutely. And this, I may have mentioned it already today, but this is the type of question where I think you can take this, even if you don't nail it the first time, and then practice it. So, I'm going to go and do this problem several times. So hopefully kind of line by line, looking at the GitHub code base that you have, but then try to do it again from scratch, or at least from my notes, and then maybe a third time, right? So then when I come across this type of problem, it's kind of a little bit more ingrained than like, I don't know where to start, right?
Yeah. Or if there's a way you want to do, like, so for instance, that make change problem that I joked about completely failing with Joe.
Yeah.
One of the times I was riding home on the train, I was just like, let me just solve that recursively. And so, you can force yourself to do different ways of solving the same problem. So
Yeah, absolutely. Great. Well, thanks so much, Jeff. Thanks for being on.
no problem. Thank you.
Cool. I'll end it there. Thank you. I realized like I wasn't going to be able to do something like this, at least not without stumbling, bits and pieces through the whole thing. But I don't think I've had something like this on the show where I actually talk through something that was a little bit more like actually object oriented. So that I think would be helpful for people who are, basically like me, who haven't done this type of interview before. Literally walking through it is helpful. So I appreciate that.
Thank you for watching the technical interview portion of the Professional Technical Interviewee. If you want to tackle this interview question, you can find it at github.com/professional technical interviewee. New episodes are released on the first 4 Thursdays of each month. Find us on YouTube at youtube.com/Dorsett or on Apple Podcast or Spotify. Make sure you subscribe so you don't miss out on new episodes. And remember, keep practicing.